Hey Geometry, so today we're going to take a look at 4.8, which is using the coordinate plane, looking at triangles in the coordinate plane, and attempting to identify what type of triangle it is we're dealing with based on that. So the first thing I'll recommend is plot your points. Sorry about the copy quality of this grid, just kind of eyeball it as best you can. So I'll go through this for the first one with you. So A is at -2, 1, so -2 about there, 1, I don't know, right about there. And I'll label that as point A, but I kind of like to get the other points down so I know which side to label it on, whether I don't know where the inside of the triangle is going to be over here, over there, so I'll wait a second to do that. B is at 2, 3, so 1, 2, up 3, maybe there-ish, right? Kind of hard to see. And again, C will be, one of these directions. We'll figure that out, and then I'll go back and label those. And C is at 0, 7, so it turns out C is up here. And so now I can say, all right, that was C, this was B, that was A, and draw my triangle between those. All right, now ultimately our goal is to identify this triangle. I wanted to identify it both by sides and by angles. All right, so the easier way, and this really process just kind of takes a while, is to do it by sides. So effectively we have to do Pythagorean theorem 3 times. Distance formula is really what it is, but it's Pythagorean theorem. AB, BC, and AC, or CA, whatever. All right, so when you're doing this, yeah, you can try and do the whole fancy distance formula, right? So it's like x2 minus x1 over y2 minus y1. Really, it doesn't matter which order you subtract in, since we're just kind of looking at horizontal distances, right? Effectively here, I'm looking at this right triangle here, straight across and straight up here from A to B. So just you can kind of count out the horizontal distance. Now again, our grid's not great. We're going from here at -2, 1 over to B, which is at 2, 3. So I went from -2 to 2 horizontally. So I traveled a distance of 4. It doesn't matter where we go 4 or positive 4 or -4 in the end, because effectively that's getting squared. So I'm just going to stick to the positive distances always. I'm not going to ever worry about when it's negative, because everything's getting squared as part of that Pythagorean theorem distance formula. And then as we travel up, our distance up was 2. So 4 squared plus 2 squared, and then ultimately we're going to take the square root. So a squared plus b squared equals c squared, the hypotenuse, but then we solve for the hypotenuse and take the square root. So the distance from A to B is going to be 16 plus 4, which is 20, and the square root. And I'm going to leave it just like that. You don't need to reduce it, don't need to actually, rationalize, or simplify. Just square root of 20 is good. Square root of 20 is a number. I can tell, if I figure out another square root, I can tell which one's bigger. That's all we really need from this. And also later on when we go back to check for angles, that's great. All right, so then BC, our horizontal distance, and I'm going to just kind of go from left to right, from C to B, from 0 to 2, so that horizontal distance is 2. That vertical distance is from B is at 3 up to 7, so that vertical distance is 4. Again, it doesn't matter that we're going down or up, because these numbers are both getting squared, and then we're going to take the square root of them, and you might recognize that there we go, same exact distance. So we're dealing with at least isosceles. Let's see if that third side is the same. You can probably guess it's not, but it seems like we're dealing with an isosceles triangle here. So A to C, horizontally, we're going from -2 to 0. So that horizontal distance is 2 squared plus the vertical distance. A starts at 1, and we end up at 7. So that's a vertical distance of 6 squared. Yep, that is obviously not the same. So 6 squared is 36, plus 4 gets us to the square root of 40. Which is not the same. So based on these 3 distances, I don't actually know exactly what those numbers are, like what is the square root of 20, what is the square root of 40. I could type them into my calculator and see what the decimal is. Doesn't matter. I know 2 of them are the same, 1 is different. This is an isosceles triangle. All right, and then here's what's pretty cool about this. If we have those 3 sides, I'm going to take my 2 shorter sides. I'm going to see if this is a right triangle, right? Remember, we're going to check for angles. I'm going to check by seeing if it's a right triangle, and if it's not, then I'll know whether or not the hypotenuse was too big or too small, and we can decide whether it's obtuse or acute. So I'm going to take these 3 sides. I'm going to do the square root of 20 squared. Well, that's easy. That's just 20 plus the square root of 20 squared. I'm going to pick my 2 smaller sides. Does that equal my third side, my perspective hypotenuse, square root of 40 squared? Well, all right, so that is just 20. 20 plus 20 equals 40. Yeah, that works out. So what does that mean? That means Pythagorean theorem worked out. That means that this is a right triangle. So, and you could probably spot that out. Now, this appears to be a right triangle, and these lengths are the same. That is an isosceles right triangle. So I'm going to repeat that process over here. I'm going to go ahead and draw my triangle. Hopefully you can graph your triangle, but then I'll come back and show you some of those calculations. All right, so here we go. We've got our 3 points on there, and those points are plotted. So we're going to calculate some distance. We're going to need to find both MN, NO, and OM, or MO, whatever way you want to do it. So finding those distances, again, M to N, horizontally, we're going from, and we can look up at our x coordinates to verify, since like I said, this grid is not great. Horizontally, we're traveling a distance of 8 from -1 to 7. So it's going to be 8 squared plus, and then our vertical distance from M to N. So we went from -3 down to -6. -3, 1, 2, 3. We went 3 down, so that's 3 squared, and the square root of that. So that's going to be 64 plus 9 is 73, and that's great. Square root of 73, whatever that is, that's a number. All right, so then we'll move on to NO. So from N to O horizontally, we're going from 7 to 10, so that distance is 3 squared. Vertically, we're going up 3, so that is 3 squared, and so 9 plus 9 squared to 18. Okay, those are different lengths. And then finally, OM. Well, this is actually kind of an exception. You could do what we're doing, but there is no vertical distance. There's just horizontal distance where they're both values are at -3. So we just went from -1 to 10. So you could do like 11 squared plus, but then the vertical distance is 0 squared and then square root, but you're just going to get 11. Right, this literally comes out to 11. You can write it as square root of 121 if you want, to whatever, if that helps you to get it all in the same format, but it ultimately is just 11 for that distance. All right, so then we go, all right, so what do we got? We have scalene triangle. Those are all 3 different sides, so 3 different lengths. And so then we're going to go through and check our Pythagorean theorem. Do we have a right angle here? And we're going to use our 2 shorter sides, which, again, don't be confused by that being 11. That actually is, it really is square root of 121, which is the biggest side. It is 11, though. So we're going to do, like square root of 18 squared plus the square root of 73 squared equals, you could write the square root of 121, squared, or you could write 11 squared. Ultimately, it's just going to be 121, whatever way you do it. So we get 121 is 73 plus, so 18 plus 73, 121, not quite. So I wrote that equal sign. I probably should put I'm going to put a little question mark there to just see if it's, turns out ultimately, if you add that up, this ends up being, what does this end up being? 91, I think. I did that right? 91 is less than 121. So we were checking to see if this long side was our hypotenuse. Turns out it was a bit too long. So that means that this angle here is obtuse. That this was bigger than, that this was 90 degrees, it would have been smaller. This was a bit too large. So that means we're dealing with an obtuse triangle. And so we have a scalene obtuse in that one. All right, I'll go ahead and draw on this next one. All right, so got our triangle graph there. I got a little less space down here, so I'm going to start this one up here doing these distances. So GH, horizontally from GH, it's at -3 and -4. So that's just a horizontal distance of 1. Again, not caring about whether it's positive or negative because it's squared, which is just 1. And then the vertical distance is 2, from -2 down to -4. We traveled a distance of 2, so 2 squared. And then we'll take the square root of all that. So that's 4 plus 1 is 5. So we got a square root of 5 distance. HI, we're going a horizontal distance of from -4 to 0. So horizontal distance is 4 across. And then we're going from -4 to -6 down 2. So 4 squared plus 2 squared. So that's 16 plus 4. So that's that square root of 20 distance. And then IG, that distance there, horizontally we're going 3, so that's going to be 3 squared, plus vertically we travel from G, which is -2 to -6, we travel a distance of 4. So it's 3 squared plus 4 squared. You might actually recognize that's our Pythagorean triple. So right, 9 plus 16 is 25. Square root of 25 is 5. So I'm going to write square root of 25 because I think it's not bad to have a reference for where that is, but that ultimately is 5. All right, that's that nice Pythagorean triple. Well, the distances are all different, right? Square root of 25, square root of 20, square root of 5, so that is scalene. Then we want to analyze whether or not it's a right triangle or not. So we'll take our two shorter sides, which are the ones here, right? This was square root of 25. That's why I wrote it that way, because sometimes it's weird to think, oh, is 5 actually bigger and smaller? It's the biggest side. So we're going to do square root of 5 squared plus the square root of 20 squared. Does that equal, you could say the square root of 25 squared, or you could just say 5 squared, whatever way you want to say it. Ultimately it is 25. Does 5 plus 20 equal 25? Yes, it does. We've got a right triangle. So that is a right triangle. All right, one more. All right, so this time around, AB. Again, we could do the whole like vertical distance squared. So we could do like the or horizontal distance squared plus the vertical distance squared. This really is unnecessary because it's just the square root of 2 squared, which is just a distance of 2. So you could say the square root of 4, but it is just 2. And you could have seen that immediately by just saying, oh, 1, 2. It's straight up a line. It's a distance of 2. But I want to, you can do it either way. B to C, our horizontal distance, we're going from 0 up to 6. So that is going to be 6 squared plus our vertical distance is going to be from 2 up to 6. So that's going to be a 4 squared. So 6 squared, 36, plus 4 squared, 16 is, what is that? 36 plus 16, getting lazy, is 52. So we got a square root of 52. Get it in there. All right, whatever number that is. And then our last distance here from A to C, we're going, horizontal distance is still 6 squared, vertical distance is 6 squared, so 36 plus 36 is 72. And that's our longest side, all three different, so we have a scalene triangle. No repeats in those distances. And so then let's check Pythagorean theorem. So again, we could go square root of 4 squared or 2 squared. So these are our shorter sides here. So it would be, I'll do the square root of 4 squared. Like I said, you could have done 2 squared. It's going to be 4 plus the square root of 52 squared. Does that equal square root of 72 squared? So no, this is going to be 4 plus 52, which is not equal to 72. So does it equal that? Now it turns out that that is 56, which is less than 72. Our perspective hypotenuse in this situation, AC, was too long. So that means that this angle here was obtuse. So we are dealing with an obtuse triangle once again there. So there is some check-in for what type of triangle you're dealing with in the coordinate plane.